All right, here's the next problem then, problem number 39. It says it wants you to simplify this expression so that you have x to the r over y to the t. So we're going to have to simplify this using our properties of exponents. So I can bring the 2/3 to everything, in which case it becomes 5 times 2/3, which is 10/3, and then y to the 2/3 all over y, and then 4 times 2/3 gives me 8/3. All right. Now it wants y on the bottom, so I need to take this y right here. I need to move that to the bottom. So in order to do that, I'm going to have to make it negative. So I'm going to move it down and make it negative 2/3. Okay, and then from there I can simplify it because when you multiply like bases, you add the exponent. So I need 8/3 plus negative 2/3, which is just 6/3. So this becomes 6/3 in the bottom. So it'd be x to the 10/3 over y to the 6/3, which is x to the 10/3 over y squared. So right here, they're looking for the exponent, which is 10/3 on x, and then on y, they're looking for the exponent on y, which is just 2. Next problem then, it says simplify the following expression as much as possible. So you guys are going to have a big expression like this, and you're going to have to take the cube root of everything. So the cube root of 27 is 3. And then x to the 10th is going to be x to the 10/3 because these radicands right here go in the denominator of the fraction. So then it'd be y to the 7/3 all over. The cube root of 8 is 2. And then it'd be x to the 4/3, y to the 1/3. All right, I can simplify this from here. Obviously, 3/2 stays out front. I can then do x to the 10/3 minus 4/3, and that gives me 6/3. So it's going to be x to the 6/3, which is really x squared. And then the next one, y to the 7/3 minus 1/3 gives me 6/3 as well, which is really just 2. So it's really y squared. So this goes right there. Next problem then, using laws of exponents, we write the following expression as a quotient. So you can make this 6 to the a over 6, because when you have like bases and you subtract, you end up with 6 to the a minus 1, because this is a 1 right there. So you can rewrite this as 6 to the a over 6. You're going to have to use the caret as well, caret a. Next one says, using laws of exponents, we write the following expression as a product. So it wants us to simplify this thing. So we have 5 times 10 squared is 100 times t squared times e to the 3t would be e to the 6t. And you have exponents, you multiply the exponent. And then I can simplify this from here. This is 500 t squared times e to the 6t. So when you enter this in, this one goes into the first one right here. This one goes into the second one, but make sure that's in parentheses when you enter in the caret. So enter it in like this right here, that in parentheses. And it does say, I entered in before, it wants both of these not to be constant. So it says evaluate the following expression without a calculator. So we're going to have to try to do this without a calculator. All right, so 27 to the 4/3. This denominator right here is really a cube root, keep in mind. So 27 cube root, let's do that first. That gives us 3. And then we can do 3 to the 4th. Okay, if you're not sure what 3 to the 4th is, without a calculator, you can multiply it out. So like you can do 3 times 3 times 3 times 3, right? 3 times 3 is 9, times 3 is 27. So we need 27 times 3. So you can do that like, you know, the lattice method or whatever you guys learned in elementary school. 3 times 7 is 21. 3 times 2 is 6, plus 2 is 81, so it's 81. Okay, so then the next problem is the same type of thing. This 2 is in the denominator, so I'm going to do the square root of 25 first, which is 5. So we have 5 cubed, which is just 125. Like I said, if you don't know that, you can just do 5 times 5 times 5 and just multiply it out one at a time. So that's 25 times 5, and you can just do, you know, the 25 times 5 like you did in elementary school. And that'll give you 125. Okay, same thing with the next one. Square root of 100 is 10. 10 to the 7th now is what I want. 10 to the 7th, you guys can just, you know, write out 7 zeros for that. Yeah, so I just enter in 1, 2, 3, 4, 5, 6, 7 zeros. All right, next one wants the cube root of 125. That's going to be negative 5. you can't take the cube root of a negative number, because keep in mind, -5 times -5 times -5 gives you double negatives cancel, and you get -125. So to go backwards, the cube root of -125 is the -5. Okay, the next problem says evaluate the following without a calculator. So we can, -7 squared gives you a positive 49. The square root of positive 49 is positive 7. All right, next one. -1 to an odd power gives you -1 back. Because think about it, if you do -1 times -1 times -1, the even signs will cancel, and the third one's going to make it negative again. So anytime you have an odd number of times you're multiplying a negative number, it's still negative. So that's really -1 times the square root of 49, which is -7. Next one, 0.49, and we want that 1/2. I'm trying to do this without a calculator. So we're trying to take the square root of 0.49. This would be 0.7. Next one, same thing, -125. Let's do the cube root first. So the cube root of -125 is -5, and then we're going to square that. So -5 squared gives you positive 25. Okay, so the next one says simplify each expression as much as possible. Leave it without radicals. So the square root of W4, that's really, right, the square root's really dividing by 2. So it's really, put these 2's in the denominator of each of the fractions. So that'd be W squared, and then x to the 4th. Same thing with this one, 27. This is really a cube root, so that'd be 3. Cube root of 27 is 3. And then 6 divided by 3 is 2, so it'd be W squared. Same thing here. Square root of 36 is 6. X to the 6th, the 6 divided by 2 gives you x to the 3rd. And then y squared divided by 2 gives you y to the 1st. And the last one's a little bit more complicated. We need to square root everything. We can actually put the square root over everything and multiply these together. So 32 times 2 is 64. W to the 9th times w to the 5th is really w to the 14th. And then y to the 4th times y to the 6th is really y to the 10th. And then square root of 64 is 8. Square root of w to the 14th puts the 2 in the denominator of this fraction, so it'll be w to the 7th. And then y to the 10th square rooted puts the 2 in the denominator, so it'll be y to the 5th. Okay, next problem. Enter equal if the proposed identity holds, and if it doesn't. So when you square this, you actually get this quantity right here. So that's definitely not true. This one is. Right, you got to FOIL it to get the middle terms. When you square this quantity, you do get the middle term again, so that's not true. But this one is right here. And this is a difference of 2 squares, which does follow this pattern right here. So if you have like x minus 2, x plus 2, that is the same thing as x minus 4 squared. I'm sorry, same thing as x squared minus 4, which is exactly what this is saying. That's a difference of 2 squares. It's a pattern that you're going to have to memorize. One of the few things you'll have to memorize, hopefully. All right, next one says enter equal if the identity holds and if it doesn't. So we're asking, are these the same thing as this right here? I'd probably just check. I mean, you can try to simplify this to look like this by multiplying the top and the bottom of this one by y, and the top and the bottom of this one by x. And you're not gonna be able to work it down to this. So I just try it with numbers real quick to see if it works. Try 1 for x and 2 for y, and see if it equals 1 over 3. So does 1/3 equal this? Well, multiply the top and the bottom of this one by 2, and you get 3 halves. So 3 halves is not the same as 1/3, so that's not true. We just tried it with 2 numbers for x and y, and we found that it didn't work. So if there's one counterexample for an equation, then the whole equation is false. Next one, same thing. I'm just going to try it with numbers again. So I'll try 1 for x and 2 for y again, and see if that equals 1 plus 2 over 1 times 2. So that's 3 halves here. Here, 2 times 2 give me 3 halves. So 3 halves does equal 3 halves. So my guess is this identity does hold true. We can try it with algebra though, just to make sure. So multiply top and bottom by y, so it'll be y over xy. multiply top and bottom of this one by x, it'd be x over xy. And when you add that together, you do get x plus y over xy. So we did do it with algebra as well to prove that that is an identity. So dividing by a fraction is the same as multiplying by the reciprocal, so multiply by d over c, which that's really AD over BC. So put AD here, BC here. This was just testing to see if you can FOIL. So when you FOIL this out, 7x times 5x, 35x squared, plus 6 times negative 2 is a negative 12. I'm sorry. 7x times negative 2 is a negative 14x. 6 times 5x is 30x. And then 6 times negative 2 is a negative 12. So add these together, and that gives you 16x in the middle here. And so A is 35, B is 16, and C is negative 12 for me. All right, so 50 wants you to find the product between these two, so you're going to have to FOIL. First times first is xy. First times second is 7x. Second times first is negative 4y. And then negative 4 times 7 is negative 28. Unfortunately, you're going to have to enter that in like it is because there's no simplifying this. So you're going to have to go ahead and type all that in. All right, next problem wants you to subtract these two quantities. So we're looking for like terms. Like terms are wherever you have the same variable with the same exponent. So a to the fifth, b to the fourth, a to the fifth, b to the fourth. These are like terms right here. So we have 5 of those minus 6 of those, which gives you 1 of those. So it's 1 a to the fifth, b to the fourth, plus, now we're looking for a to the fourth, b to the fifth, which is here and here. Those are like terms. So we have 2 of those minus a negative 5 of those. So double negatives go positive and end up with positive 7 of those. And then I have 2 minus a negative 1, which is double negatives go positive, you end up with 3. So I would have to enter this in, which is a lot of work, but that's my answer to enter that in. And I made a mistake. This is 5 minus 6 would be negative 1 of those. Okay, next problem is 52. It says factor this trinomial right here into, this is actually a perfect square trinomial because of this pattern right here. So it's going to be, basically you're going to have the same factor twice. That's what this says. So you're going to have, you know, ax minus b times ax minus b. So the question is, what two numbers multiplied together would be 25, that'd be 5. And what two numbers multiplied would be 16, that'd be 4. So this is what you get, 5x minus 4 times 5x minus 4, where a is 5 and b is 4. All right, next one says the same thing. It wants you to factor this trinomial. This time it's two different factors because it's got ax minus b times cx minus d. So a, b, c, d are all going to be different numbers. So we need to try to find a way to factor this. You can guess and check with these. The other thing you can do is what's called factor by grouping. All right, if you didn't want to guess and check on this one, you could use the factor by grouping. So what you do is you multiply the first and the last two terms together, and then you want two terms to add to be negative 75. Turns out that's negative 35 and negative 40. So what I'm going to use is negative 35x and negative 40x, because those multiply together to be positive 1400x squared, and they add to be negative 75x. So what I'm going to do now is write this as 40x squared minus 40x minus 35x plus 35. Now it doesn't matter what, all I did was replace the middle term, negative 75x, with the two factors that we found. And it doesn't matter what order you put them in. I could actually switch these two, but I did it like this. That's fine. Now you're going to factor by grouping. So you're going to pull 40x out of the first two, and that leaves you with x minus 1. And then I'm going to pull 35 out of, I'll actually pull negative 35 out of the next two, which leaves me with x minus 1. And now from there I can factor out the x minus 1, and that leaves me with 40x minus 35. So I don't know if guess and check would have been just as easy for this one, but that's what we're looking for there. It doesn't, I don't think it matters what way we enter this n. Just enter in 1 for A, for example. B will be 1 as well. And then C would be 40. And D would be 35.